Hello, Applied Physics students. Here are your homework number 10 corrections. Question number 1. How can you be both at rest and also moving about 107,000 kilometers per hour at the same time? This has to do with that idea that motion is relative. Okay. You're at rest relative to the earth because you're not moving from spot to spot on the earth. However, if you would compare yourself to the sun, you're moving 107,000 kilometers per hour relative to the sun. So again, this is getting at that idea that all motion is relative. It depends on what you're comparing the motion to. Question 2. You cover 10 meters in a time of 1 second. Is your speed the same if you cover 20 meters in 2 seconds? So remember our equation for speed equals our change in distance over our change in time. So in the first instance, our speed is 10 meters in 1 second, so 10 meters per second. The second one is if your speed the same if you cover, speed is, again, change in distance over change in time. If you cover 20 meters in 2 seconds, 20 divided by 2 is 10 meters per second. So, is our speed the same? Yes. Our speed is the same. We went twice as far in the second example, but we also took twice as much time. Number 3. Does the speedometer of a car read instantaneous speed or average speed? Remember, we talked about that in our notes. Our speedometer always tells us instantaneous speed. That's why it's always changing. Okay, so our speedometer tells us our instantaneous speed. Number 4, average speed equals distance covered divided by travel time. Do some algebra and multiply both sides of this relation by travel time. What does the result say about distance? So, average speed equals distance covered divided by travel time. And it says to multiply both by travel time, which means travel time is crossed out on this side. So what does the result say about distance covered? Distance covered, if we want to figure out how far we've gone, we're going to take our travel time and multiply it by our average speed. And again, this is this idea that you use when you're planning a trip. If you want to know how far you're going to get in a day, okay, or that sort of thing. Number 5. Which is a vector quantity, speed or velocity? Defend your answer, okay? Remember, our vector quantity is a velocity, which means that it needs a magnitude, or we call it size, and a direction. Speed, remember, is a scalar quantity. Okay. It only needs a size. Number 6, what two controls on a car cause a change in speed? What control causes a change in velocity? So for speed, remember speed doesn't have direction. So for speed, okay, it would be the accelerator and your brake. What control causes only a change in velocity? That's your steering wheel, because you're changing your direction. Now, all three of them can cause a change in velocity because remember, an increase or decrease in your speed is also a change in velocity. But your steering wheel is the only one that is causes only a change in velocity. So these really would be a change in speed and velocity. Number 7. What is the acceleration of a car moving along a straight line path that increases its speed from 0 to 100 kilometers per hour in 10 seconds? So our equation for acceleration is that it is our change in speed because we're on a straight line path. So I'll use change in speed over our change in time, or our time interval. So it increases its speed. So speed number 1 is 0 kilometers per hour. Speed number 2 is 100 kilometers per hour, it tells us in the problem. And our change in time is 10 seconds. So speed 2 minus speed 1 divided by our change in time, 100 kilometers per hour minus 0 kilometers per hour divided by our 10 seconds. So that gives us 100 kilometers per hour divided by our 10 seconds, which gives us 10 kilometers per hour second. Number 8. By how much does the speed of a vehicle moving in a straight line change each second when it is accelerating at 2 kilometers per hour per second, at 4 kilometers per hour per second, at 10 kilometers per hour per second? So we want to know how much the speed changes, okay? And so remember, we have those equation manipulations in your notes. So if we want to know our change in velocity, it's our acceleration times our change in time. And notice in our problem here, our delta t is 1 second because it tells us each second. And they give us 3 different accelerations. So our change in velocity for our first example is 2 kilometers per hour second times 1 second, which gives us 2 kilometers per hour. Okay. Our change in velocity in the second one is 4 kilometers per hour second times 1 second, which gives us 4 kilometers per hour. And our change of velocity number 3 is 10 kilometers per hour second times 1 second gives us 10 kilometers per hour. So those are our change in speeds for these 3 vehicles: 2 kilometers per hour, 4 kilometers per hour, and 10 kilometers per hour in each second. Number 9, why does the unit of time enter twice in the unit of acceleration? Because our equation for acceleration is our change in velocity over change in time, and because our equation for change in velocity is the change in distance over change in time. So what that means is if I kind of substitute that in here, I have change in distance divided by change in time times change in time. So I have 2 times here, okay? And so that's why we get 2 units of time in our accelerations. Question number 20. Rank each of the following sets of scenarios in order of the quantity or property involved. List them from left to right. If scenarios have equal rankings, then separate them with an equal sign. Example A equals B. Jogging Jake runs along a train flat car that moves at the velocity shown. From greatest to least, rank the relative velocities of Jake as seen by an observer on the ground. Call the direction to the right positive. So if we're going this way, we're going to say it's a positive direction, which means if we're going this way, it'll be a negative. And again, we're pretending that we're a person standing on the ground here and seeing this, right? So in letter A, I have a positive 8 meters per second plus a negative 4 meters per second because it's negative because he's going the other direction. So positive 8 minus 4 is 4 meters per second. And it ended up positive, so that means that from the ground it looks like he's moving to the right. In letter B, I have a negative 10 meters per second for the train plus a positive 6 meters per second for the runner. So minus 10 plus 6 is a negative 4 meters per second, which means it looks to me like he's actually moving backwards on that train. He looks like he's moving to the left. Letter C. Again, I have a positive 6 meters per second for the train plus a positive 4 meters per second for Jake. So that gives me a positive 10 meters per second, which means on the ground it looks like he's moving to the right at 10 meters per second. And letter D, I have for the train a positive 18 meters per second plus a negative 6 meters per second because he's moving to the left. So 18 minus 6 is 12, but it's positive meters per second, which means it looks on the ground like he's moving to the right. So when we rank these then, the most to the right would be letter D first, then letter C, then letter A, then letter B. I hope that helps if you had some questions on your homework. Have a great day. I'll talk to you tomorrow.